Okay, now what we'll have, we'll move to the first unit. So anyway, we have only 8 units. Okay. So for this, okay. Now the first part is anyway, it's all about the representation of data. When it comes to data, so in our statistic world, actually, we have data and information. So data means actually for the raw unprocessed ones, but for the information is actually the processed data. Now, what will happen here for the chapter 1, representation of data? If I move to the theory part, okay, okay, this one. Why do we collect, display, and analyze data? We can collect data by gathering and counting, taking surveys, giving out questionnaires, or by taking measurements as well. Normally, we display all these data as well as we analyze all these data so that we can describe the things, both physical and social methods, and also that we see and experience around us. Normally, we can also find answers to questions that might not be immediately obvious, and we can also identify questions for further investigations as well. Normally, we do some experiments, and then, according to the results, only we come to kind of conclusions. That's how it works. So improving our data handling skills will allow us to better understand and evaluate the large amounts of statistical informations that we meet daily. So maybe it's mean, medians, mode, not only that, there are like so many things which we can analyze statistically and come to some kind of conclusions. So we find it in the media and from elsewhere, sports news, and weather forecasting news, product advertisements, weather updates, health records, and with our environmental reports. All these ones are like those are kind of different domains which the data actively and updated. So, through activities that involve data handling, we naturally begin to formulate questions. So, this is a valuable skill that helps us to make informed discussions, and also we also acquire skills that enable us to recognize some of the inaccurate ways in which data can be represented and analyzed, and to develop the ability to evaluate the validity of someone else's research. First part is anyway the type of data. When it comes to types of data, we have two different categories. One is qualitative, the other one is quantitative. Qualitative, and the other one is quantitative. So when it comes to qualitative data, we called another name as categorical data. Categorical data. So in Sinhala, we called it as Gunatmaka. Qualitative means Gunayak. Gunatmaka data. That. And for the quantitative ones, there's no any special names. That is actually in Sinhala, we call it as Pramanatmaka. It's related to quantity. Pramanatmaka datta. Those are the two different categories which we have in data. One is qualitative data, the other one is quantitative data. Now, what will happen for this qualitative data and quantitative data? There are two types of data, qualitative or categorical data are described by words. So, for example, it will be like t-shirt size, small, medium, large, extra large, that also coming under qualitative data. And for the quantitative data, what else we have? Blood types, positive or negative. Likewise, there are also, there's no any proper numerical values for those ones. එතකොට for those kind of values, for those kind of data, those are coming under qualitative or the categorical data. And
Okay.
yes, and the quantitative data, actually we can call this as non-numerical data, and this one as numerical data. Numerical data. All these three names, hammer, namakimma, we call the same thing. Now, what will happen here for the quantitative data? If it's quantitative data, those take numerical values and are either discrete or continuous. මෙතන ගත්තාම for the continuous data, we have two separate categories under that. එකක් තමයි discrete data, the other one is the continuous data. එකක් discrete data, the other one is the continuous data. As a general rule, for the discrete data කියලා කියන්නේ, if we can count it like this, 1, 2, 3, 4, 5, ඔය විදිහට count කරන්න පුළුවන් නම් with whole numbers, then those ones we call them as discrete data. But
Okay.
continuous data, weight and the height, those ones are coming under continuous data. For example, someone can, so for example,
Like there's a range, right?
yes, Anna Hari. If it's me now, I can say my weight as 60 kilos. And someone else can say it as 60.1. Someone else can mention it at 60.75. See, here there's no any decimal points. Here we have 1 decimal point. Here we have 2 decimal points. We can't restrict. It's a
Yeah.
kind of a continuous, there's a kind of a continuity. Because of that, for these kind of variables or for these kind of data, we call them as quantitative data. Under that quantitative data, we have two different methods, two different categories. One is discrete and continuous. These are coming under continuous. If we can count it like 1, 2, 3, then potaka pitunang pages of a book now we can count now. These ones are the discrete. That's the difference. So here discrete data, whereas continuous data are measurements that are given to a chosen degree of accuracy. So discrete data can take only certain values as shown in the diagram, or a decimal floating points it won't. These are like perfect whole numbers, and the numbers of letters in the words of a book is an example of discrete quantitative data. So each word has 1, O2, O3, O4, O letters. There are no words with the fractions, decimals, floating numbers, these ones. Because of that, those ones should be in perfect numbers. So the discrete quantitative data can take non-integer values. For example, countries, name of the countries, then it will be United States. Coins have dollar values. They have a 0.01, 0.05, 0.10. See, the decimal places are there. In Canada, the UK and other countries show sizes such as 6.5, 7, 7.5 are used like that. So what will happen for the continuous data? By according to the given context, we can't like අපිට මේ වගේ values කියලා differently consider කරන්න බෑ. Thus we have a proper range. The times taken by the athletes to complete a 100 meters race is an example of continuous quantitative data. We can measure these to the nearest second, or maybe it's to the nearest tenth, or maybe it's nearest to the seconds, or even more accurately if we have the necessary equipments like that. So the range of times is limited to positive real numbers. That is it. Now we have to have representation of discrete data, stem and leaf diagram. So this one you already know. I hope you already know. No, right?
Yeah, we did it in maths.
ඒක තමයි. So for example, but I'll go through with the special words what they have highlighted. When it comes to stem and leaf diagrams, what will happen? So a stem and leaf diagram is a type of table best suited to representing small amounts of discrete data. Here, the last digit of each data value appears as a leaf. So what will happen for these one, we call them as leaves, and for these ones, we call them as stem, attached to all the other digit which appear in a stem. So the digit in the stem are ordered, these values are ordered vertically. Sorry, these values are ordered vertically, and the digits on the leaves, these values are ordered horizontally, with the smallest digit placed nearest to the stem. See, this one is an unordered one, but the proper method is to order it. That's what they have represent here. So here we have the stem values, here we have the leaf values.
Okay.
Each row in the table forms a class value. These values are, we call them as class of values. It's kind of a group, no? Because of that, we call them as class of values. So the rows should have intervals of equal width to allow for easy visual comparison of sets of data. Now what will happen? A key with the appropriate unit must be included to explain what the values in the diagram represent. So here the row data, stem and leaf diagrams are particularly useful because row data can still be seen. The actual data, we can't get a kind of a proper idea, but before start doing any analysis or representations, it's easy for us to what is the minimum value of our data set, what is the maximum value of our data
Yeah.
set. Then those values we can find those outputs like at a glance. So and two sets of related data can be shown back to back for the purpose of making comparisons as well. So consider these ones. First, anyway, we need to like roughly we need to separate the stem and the leaves values, and then we need to make it as an ascending order. That means smallest to largest for the leaves values. So next we arrange the scores in each row in ascending order from left to right and add a key to produce a stem and leaf diagram shown below as well. So here in a back-to-back stem and leaf diagram, the leaves to the right of the stem ascend left to right, and the leaves on the left to stem ascend right to left as shown in worked example. Anyway, we already know that one. Okay, look at this example whether it's clear. Worked examples one.
Yeah, teacher, but this in the stem 0, 1, 2.
Yes, so what has happened there? Then that means actually the number of days on which rain falls in a certain town in each month of okay, year 2016, Jan 17, okay, February 7, okay. Display the data in a back-to-back stem and leaf diagram and briefly compare the rainfalls. If it's 0, that means 0, 1, 5, 8. Okay, for 26. Harini, for 0 comes or one digit values. Here 0, 1, 5. For those ones, they are representing that. 0 ke like 0, 0. 1 means 0, 1.
Uh-huh.
For the September, na, if it's 0, 5. Those values were, so for the stem, as for the stem, they use 0. within
Yeah.
0, 1, 05, 08, 09. The actual values are these ones. June 8, June 9. මේව තමයි එතනින් represent කරලා තියෙන්නේ.
I thought in the stem we should have the month, right?
No, 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 no. No, right? No, no. So represents, see, they have 506, no, represents 5 days in a month of 26 and 6 days in a month of 27.
Mm.
No, it's not like that.
Yeah. Okay, teacher.
Okay. Right, this example is homework, but we'll do only the, shall we do only the sixth and the seventh question? In,
Okay.
okay, in class questions. The others you can do it.
Teacher, in the Sixth question, part A. What do they mean by rows of width? Fine.
Rows of width 5. Rows of width 5. With
Part A.
okay, represent the data in a back-to-back stem and leaf diagram with rows of width 5. Width 5. Width 5 means here. Anyway, the stems would be, one is, okay, width 5, right? 1, 2, and only 1 and 2 is there, right?
Yeah.
Okay.
And 3 is there.
3 also there. Okay. Represents the data with rows of width 5. I think, what does that means? With rows of width 5. Okay. So here we group, okay. So here, that means actually now what will happen? We group the values for the months of each year into classes. We are grouping here from 0 to 9 into 1 month, 10 to 19 into 1 month, and 20 to 29 into 1 month. And then arrange the values in each class in order with the key as shown. No information is given about the amount of rain that fell, so it would be a mistake to say that more rain fell, okay, than this. What about the okay narrower class on? But anyway, we can't like represent it as class intervals, no. Anyway, we have to
Yeah.
keep a oh, that one you can just neglect and do it. If rows of leaves are particularly long, repeated values may be used in the stem, but this is not necessary in worked example 1.1. However, if there were say 30 leaves in one of the rows, hari. මේක කියන්නේ එක වැලියව එකකට ගොඩාක් ඔක්කොම එක දිගට දාන්න නැතුව just put only 5 numbers. එකක් නම් මෙතන පහක් ලියලා ඊට පස්සේ ආයි ඉතිරි ටික යටට යන්න. දැන් for example, see here multiple values එනවා නම් this is the question. So if you
Yeah.
like put it 1, 2 and 3. So here 2, 8, 1, 3, then 7. Again 1, 3 වලට පස්සේ again 0 and 9, 4, 3 likewise. No? So now 5 is completed for a single row. No? Then you have to
Mm.
again write the next one in the next line. එක row එකකට 5 numbers එන්න තමයි ලියන්න කියලා තියෙන්නේ.
Okay.
Yeah, because here they have mentioned it. We didn't read the tip, no. So yeah, values may be used the stem, but this is not necessary in worked example 1.1. However, if there were say 30 leaves in one of the rows, we might consider grouping the data into narrower classes. එතකොට අපි කරන්නේ මොකද? Narrower classes කරනවා 0 to 4, 5 to 9 අර like that. එතකොට ඔතන width එකක් consider කරන්න කියලා තියෙනවානේ පහ පහ අරගෙන. Then
Yeah.
and 20 to 24, this would require 0, 0, 1, 1. එතකොට අපි කරන්නේ අර multiple rows 0, 0, 1, 1, 2. Likewise, we just represent it as මේ මොනවාද stems. අර බිඳුව කියලා
Okay.
කියන දෙපාරක් එනවා. That's what there they have mentioned. හොඳයි අපි.
Okay.
Uma coisa. Olha, tem hora quem quer. Ah,
Teacher,
yes.
in the seventh question, teacher, here should we find the median?
Yes, median means the middle value.
Yeah, now I know how to do that for one side, but how should we do
No,
that?
you can consider it separately, right? Here we have like two different ones, no? Two different for the girls it would be this amount and boys or else what you can do you can if you are considering this entire thing as one data set then you can arrange it from lowest to the lowest to the highest number as a row data set and then find out the middle value.
Okay. Okay, teacher.
Okay, that is done. Then the next part, representation of continuous data histograms. Again, we have to do the histogram. So here, continuous data are given to a certain degree of accuracy, such as three significant figures, two decimal places to the nearest 10 and so on. Likewise. So normally we usually refer to this as rounding. In maths also we did no rounding off and rounding down. So that's
Yeah.
what here also we are doing. When values are rounded, gaps appear between classes of values and this can lead to a misunderstanding of continuous data because those gaps do not exist. Actually, we don't have those gaps. So now what will happen? Consider heights to the nearest centimeters given. Let's assume they have given the class intervals like 46 to 150, 151 to 155. So see, now here we have a gap because if we have the length like 150.5, ඒ data එක loss වෙනවා. Because මෙතන තියෙන්නේ
Yeah.
150 වෙනකම්. Here we are starting with 151. Our middle values ටික, those will be disappeared. Then what
Yeah.
will happen? So gaps of 1 centimeter appears between classes because the values are rounded actually. Those values are not the actual values. That's the case. So using h for height, the actual classes will be how we gonna define the actual classes. Then we can like subtract 0.5 from the left side, and also we can add another 0.5 to the top. That means 145.5 to 150.5. Then the next one will start from 150.5 to 155.5. Then the next one is 155.5 to 160.5. That's how it is. See, that's how we normally find it. But remember, always the less than and equal ones come to this first part. See, this 145 value includes in here, but මේක ගත්තාම මෙතන 150.5, it's not including up until 150.5. හදිසියෙන්වත් value එකක් තිබ්බොත් there's if 150.5, this one will includes to the second range, second class interval.
Okay.
Okay, ඒක හොඳට මතක තියාගන්න because අර දෙපැත්තට දාන්න ගියාම most of the people will sometimes make mistakes on there. So the classes are shown in the diagram below with the lower and the upper boundary values and the class mid values, also called, which we call the midpoint, madhyasthaya, or the madhage, mid value, midpoint indicated. How will it happen? So the lower class boundaries, that is 145.5. So here again 150.5, 155.5. Likewise, there we have the lower class boundaries. Then the upper class boundaries are, according to this first class, 150.5 is the upper boundary. And for this class, 155.5 is the upper boundary. 160.5 is the next upper boundary. What about the class width? To find out the class width, we need to subtract the upper class boundary. Again, we need to subtract the lower class boundary from the upper class boundary. 150.5 minus 145.5. So here 155. So likewise, we need to subtract the lowest the limit or the lower boundary from the upper boundary. And to find out the mid values for those class intervals, that means we need to add those two values, I mean the class boundary values, and then we need to divide it by 2. Those are the 4 things we should know when we calculate and when we draw these histograms. So a histogram is best suited to, it's clear, right, up to this point?
Yeah.
Okay.
Yeah.
So a histogram is best suited to illustrating continuous data, but it can also be used to illustrate discrete data as well. That means, අර 1, 2, 3 වගේ calculate කරන්නේවා. If it's a continuous නම් anyway, according to, if we like properly make our class intervals, then we can properly draw that histograms. So we might have to group the data ourselves, or it may be given us to in a grouped frequency table as well, such as those presented in the tables below, which show the ages and the percentage scores of 100 students who took an examination. So here we have the age in years, and here number of students who participated and the scores and the number of students as well. So now what will happen? The first table shows 3 classes, but in the second table it has 4 classes. For this first table shows 3 classes of continuous data, See here, it stopped from 18, but again it started from 18. There's no any losses here. Because of
Yeah.
that, it's a continuous data histogram. It shows the continuous data. There are no gaps between the classes and the classes have equal width also. දෙකට යන්නේ class interval is 2 years. This means that we can represent the data in a frequency diagram by drawing 3 equal width columns in with columns with column heights equal to the class frequencies as shown below. දැන් මෙතන තියෙන ඒවා ගත්තාම දෙකෙන් දෙකට තමයි යන්නේ. See, they have drawn in, they have graphed this histogram. මුල ටික වැඩක් නැති නිසා අර ඒ ටික ඒගොල්ලෝ එකට එකතු කරනවා. That's the
Yeah.
symbol what we represent like this. Here 16 to 18 we have this amount. 18 to 20 we have 46, and 20 to 22 we have this amount likewise. But what about the second one? The following table shows the areas of the columns and the frequency of each of the 3 classes represented in the diagram on the previous page. So that means first one, it would be 2 times 34. Then the total area is area calculate karot, that is 68. Here 2 times 46, that means 92. 2 times 20, that is 40. So the frequencies will be 34, 46, and 20. The following table shows the areas of the columns and the frequency of each of the 3 classes represented in the diagram on the previous page. Now what will happen? From this table, we can see that the ratio of the columns, to get the ratio, that is 68 to 92 to 40. That means actually 34 to 46 to 20. We can simplify it further as well. අපිට තවත් simplify කරන්න පුළුවන්. Simplified version එක මේකෙන් calculate කරලා ගන්න පුළුවන්. In a histogram, the area of a column represents the frequency of the corresponding class, so that the area must be proportional to the frequency as well. Area එක frequency එකට proportional වෙනවා. That's what කියන එක we can represent it as, if it's proportional, that means the symbol will be looks like this. Area is proportional to frequency. Area is proportional to frequency. This also means that in every histogram, just as in the example above, the ratio of column areas is the same as the ratio of the frequencies, even if the classes do not here equal widths as well. Also, there can be no gaps between the columns in a histogram because the upper boundary of one class is equal to the lower boundary of the neighboring class. So a gap can appear only when a class has zero frequency.
Okay.
Zero frequency එකක් තියෙනවා නම් විතරයි. So it's clear, right? Up to this point, these ones are
Yeah.
so the axis showing the measurements is labeled as a continuous number line, and the width of each column is equal to the width of the class that it represents. So when we construct the histogram, since the classes may not have equal widths මේකට නැති නිසා, then what will happen? මෙතන තියෙන්නේ 10 ඉඳන් 29ට, 30 ඉඳන් 59ට, 60 ඉඳන් 79ට. Likewise, so here if there's no any equal widths, then what we have to do, column is equals to width of the class that it represents. When we construct a histogram, since the classes may not have equal widths, the height of each column is no longer determined. ඒ වගේ වෙලාවට we can't use the proportional height to represent that area of this what we call the column by the frequency alone, but must be calculated. So the area frequency. හැබැයි කොහොම කරත් area එක it should like proportional to frequency, but we can't make it with the column height. Column height එක because it's getting changed අර width එක වෙනස් වෙන නිසා. Is it
Yeah.
clear what I'm saying? Clear,
Yeah,
right?
yeah.
Okay. Then the vertical axis of the histogram is labeled frequency density. That's what we call the frequency density, which measures frequency per standard interval. Then the simplest and the most commonly used standard interval is 1 unit. Normally, 1 unit of measures. For example, the column representing 85 objects with masses from 50 to 60 kilogram hours. That means then the frequency density will be a complete number of objects garners 85 should divided by the class width. Class width 50 to 60. 50 again 50 to 60 means actually 10. Then 8.5 objects per kilogram. That means for example 0.0085 of objects per grams and so on. Likewise, we can calculate the frequency density. Frequency density. So for a
Yeah.
standard interval of 1 unit of measurement, frequency density is normally equals to class frequency should divided by the class width, which can be rearranged to give. Normally, if we like make the subject as the class frequency, class frequency කියලා කියන එක subject එක කරොත් class frequency is equals to class width times frequency density. That's what we have.
Uh,
In a histogram, we can see the relative frequencies of classes by comparing column areas. And we can make estimates by assuming that the values in each class are spread evenly over the whole class interval as well. Okay. Now, go through with the worked example 1.2.
oh, okay, teacher.
Okay. That is clear, right? Pretty much.
Yeah.
So here the tips are there. We can calculate the width like by using this equation. ඒක අපිට ඕන විදිහට arrange කරගෙන. So here the consider the times taken to the nearest minute for 36 athletes to complete a race as given in the table below. So gaps in 1 minute appear between classes because the times are rounded. Frequency densities are calculated in the following table. How we gonna calculate it? එතකොට gaps නැති වෙන විදිහට we need to arrange our class intervals. එහෙම class intervals අරගෙන and also it's better to have equal widths as well. එතකොට equal widths තියනවා නම් ඒක හොඳයි. But here 12.5 to 13.5. Here we have 13.5 to 15.5. That means two columns. So here we have 15.5 to 18.5. That means three columns. So
Yeah.
so here the class width is 1, here the class width is 2, here the class width is 3. Likewise. Then according to that, we can again draw the histogram. It's also clear, right?
Yes.
Okay. Then now check with the worked example 3 as well. And then we'll move to the last two questions in the exercise.
Okay, teacher.
That's it. Done. It's also clear, right?
Yeah.
That's also clear. Okay. Then exercise 1 point, explore 1.1. We'll do like only frequency tables. So we'll do only question number. Okay, we'll do only last four questions, the practice questions 10, 11, 12, and 30. Only those four.
Oh,
You do the rest of the questions at home, and if there's anything doubtful, just ask from me.
okay, teacher.
So otherwise, time is wasting.
Teacher,
Yes.
I did the 10th question, but I got different answers.
The masses in kilograms of the animals treated at veterinary clinic in the past year are illustrated in the histogram. Are illustrated in a histogram. The histogram has four columns of equal heights. Okay, equal heights. The following table shows the class intervals and the number of. Okay, find the values of A, B, and C. Okay. Okay. If they have like equal heights, then the frequency. So now what will happen here? Now the first question they ask him, find the value of A and B and show that a total of 12 animals were treated at the clinic. Okay. So now here, if I draw another row for the width, what will happen here? The width is 2, here the width is 6, here the width is 12
90.
yeah, 19, and here it is 11. Okay, and then for all these values, what will happen? We have a another common column height. No, then I'll put that height as x. ඔක්කොටම තියෙන එකම height එකනේ. So now what will happen? These are the frequencies. No, so if we multiply this width by height, then it would equals to what? It would equals to actually these frequencies, right? That's how that equation works. So that means
Mm.
6x is equals to okay. Anyway, what you have to do first, you have to rearrange these ones into the මේවත් කළත් කරන්න එපා. That means 2.5 into 2.5 to 5.5. Here we have then 5.5 up until 12.5. Then here we have 12.5 into 32.5. And then here we have 32.5 into 44.5. So that means here we have the width is 3, width is 7, width is 20, and then the width is 12. No, that's how it is. So
Yeah.
now what will happen here? So 7x should equals to 371. That means x should equals to
53.
53. Yeah. Then the height is actually equals to what? 53, right?
53, yeah.
Okay. Habai, what is the value here we have? Is it 160? No, right?
1060.
Okay, 1060. Ah, see, that's also correct, no? Because
Yeah, yeah.
yeah, 20 times 20 times 53, then we received 1060. Done with the 10th question?
Yeah, I'm in the 12th question.
Okay.
Teacher, I'm in the 13th one. Uh, hello? Okay. So teacher, in the 13th one also, should we take the class which says like to decimals? Like, should
The
we?
percentage examination scores of 747 students are given in the following table. Okay, here we have percentage examination scores of this one. Given that the frequency densities of the four classes of percentage scores are at ratios 5, 8, 13, 7. Find the value of, okay, this one. How you gone? Okay. Then first you need to like convert or get the lower limits. Then
Yeah, we have to do that there, right?
yeah, we have to do.
Okay.
Anyway, the scores, no? Yes, yes, we have.
Yeah. Okay. Done, teacher. Hello, teacher. Hello, teacher. Can you hear me? Hello, teacher. Can you hear me?
Yes, done. Sorry. Okay. So now
Yes, teacher, done.
Okay. So here, a representation of the continuous data cumulative frequency graphs. So now a cumulative frequency graph can be used to represent continuous data. For cumulative frequency is the total frequency of all values less than a given value. So as I told you, if it's a continuous noun, then uh, so now here we are going to talk about the representation of continuous data. When it comes to continuous data, first method is the cumulative frequency graph. To the cumulative frequency graphs, there a cumulative frequency graph can be used to represent continuous data, and cumulative frequency is the total frequencies. අපි අර පොඩි කාලේ කරනවා වගේම add කර කර යනවා. If we
Yeah.
are given group data, then we can construct the cumulative frequency diagram by plotting cumulative frequencies. That means the abbreviated of CF. CF means the common value should multiply it by the number cumulative frequency කියලා කියන එක තමයි we considered it as CF. So
Okay.
against upper class boundaries for all intervals, we can join the points consecutively with straight line segments to give a cumulative frequency polygon, or with a smooth curve to give a cumulative frequency curve as well. That's what they have given. That's fine now.
Yeah.
Now, for example, a set of data that includes 100 values below 7.5 and 200 values above 9.5 will have two of its points plotted at this amount. For example, they have given this kind of a scenario. Now what will happen? We plot points at upper boundaries because we know the total frequencies up to these points are precise. Because we know anyway the totals would be accurate, because of that we normally draw it. From a cumulative frequency graph, we can estimate the number or the proportion of values that lie above or below. අර cumulative එකක් නේ add කරගෙන යන එකනේ කරන්නේ. Because of that,
Yeah.
these will be above or below a given value or between two values. So there is no rule for deciding whether a polygon or curve is the best type of graph to draw. So it is often difficult to fit a smooth curve through a set of plotted points. Also, it is unlikely that any two people will draw exactly the same curve. Now, what will happen? A polygon, however, is not subject to his uncertainty, as we know exactly where the line segments must be drawn as well. Let's go through with this example. By drawing cumulative frequency polygon, we are making exactly the same assumptions that we made when we used a histogram to calculate estimates. කලින් කරපු assumptions ඒ විදිහටම we are using here as well. This means that estimates from a polygon should match exactly with estimates from a histogram as well. Okay, now look at the example 1.4.
Okay.
It's clear, right? Here L is 0, L is less than 0.5. Okay, L is less than 2.5. So again, okay. So we are adding 2. එතකොට තියෙන්නේ length will be looks like this and the additions will be first 0, then 0 plus 8, then 0, 8 plus 20. Okay, 0, 8. Okay, just check.
Okay, teacher. Okay, teacher.
Okay. So here that part is clear, right? Then they have given explore 1.2. Four histograms 1 to 4 that represents four different sets of data with equal width intervals are shown. See, now make a downwards Yaneka, make a equal heights. Here it's kind of a you will be doing a normal distributed wage bell shaped one, the histogram එකක් වගේ. Then this one will be the upwards. නැගගෙන එන වගේ එකක් තමයි මෙතන තියෙන්නේ. So for respective these ones, we have the curves as well. Which of the following cumulative frequency graph A to D could represent the same set of data as each of the histogram 1 to flow above? එතකොට මේක ගත්තොත් මේක downwards යන එකක්. Then this one should be a line like this. This one is somewhat kind like this. එතකොට මේක ගත්තොත් it would be like this. ඒ වගේ we should have a proper method to these ones. So these are kind of additional ones. Now, what will happen with okay, then we have the exercise. What does this M means?
Modeling or something.
Modeling or something. Shall we do only one question from here, only the 11th question, then move to the next theory?
Okay. Teacher, hello, teacher.
Ah, okay. Shall I do the next theory part as well and then finish? Because if we do the comparing different data representation, we are done with the first unit also.
Okay, teacher.
Okay, so it's like a summary of the entire data representation part so that you can do the exercise 1D as well as the chapter review questions, the final chapter review exercise as well. Then the first chapter also, there also we are done with that part. Okay?
Okay, and teacher, I had a small question from
Yeah.
that 11th question.
Okay.
Uh, they are teacher, they have said to draw two graphs on the same axis. So how should I name the axis?
Uh,
11th question.
then by draw 11th one, right? Okay, then what you have to do is okay, anyway, the length and this one, then what you can do, you can small on the same axis, draw two cumulative frequency graphs, one for lengths and one for diameters. How you gonna do that one? You can do like this. For the left side, if we consider the left hand side as, if we consider the left side as, if we consider the left side as what we call the length and the other side as the diameters, I
That
can
means teacher
show.
x and y axis.
Yeah, it's like this. So for this side, you may have the length. This side. For this side, you may have the diameter, and in the middle, you have the frequencies. So one graph will be like for the cumulative one, it will be looks like this, and the other one will be looks like this.
Ah,
Hemant,
okay.
that's the method. Otherwise, we can't like name two variables in same axis, no. So
Yes.
we should anyway show it separately. We can do like this. On the same plane, we can have like two y-axis.
Okay.
Okay, so I'll quickly go through with this one so that you can like do the entire exercises at home leisurely. So here for the comparing different data representations, when it comes to that, pictograms. This is kind of a summary as well and the theoretical part. Pictogram means අර අපි පොඩි කාලේ ඇඳින මල් දාලා ගස් දාලා those ones.
Mm.
So for those ones we call them as pictograms, and the vertical line graphs, bar charts and pie charts are useful ways of displaying qualitative data and ungrouped quantitative data. And people generally find them easy to understand as well, because at a glance we can conclude that. We can have a proper idea on that entire graph. Nevertheless, it may be of benefit to group a set of raw data so that we can see how the values are distributed. Knowing the proportion of small, medium, and large values of large values, for example, may prove to be useful for small data sets. We can do this by constructing stem and leaf diagrams, which have the advantage that row values can still be seen after grouping as well. For a large data set, what will happen? Individual values lose their significance, because when the data set is huge, අර එක එක data එකකට තියෙන value එක අඩු වෙනවා, because we have like more and more large amount of data. Then a picture of the whole is more informative. We can use frequency table to make a compact summary by grouping, but most people find the information easier to grasp when it is shown in a graphical format, which allows absolute, relative, or cumulative frequencies to be seen. So, although some data are lost by grouping, histograms and cumulative frequency graphs have the advantage that data can be grouped into classes of any and varied widths as well. So the choice of which representation to use will depend on the type and quantity of data, the audience, and the objectives behind making the representation. So most importantly, the representation must show the data clearly and should not be misleading in any ways as well. So the following chart is a guide to some of the most commonly used methods of data representations. Here we have quantitative data, discrete quantitative data, and the continuous data. If it's discrete data, we can have like two categories under that, ungrouped ones and the grouped ones. So if we have a grouped ones, then we have the small amount of data and also the large amount of data. So for the small amount of data, a representation, we can consider the stem and leaf one. Here for the continuous data, now we can use the histogram as well as combined frequency graph as well. Those are the graphical methods which we can use for data representation. Okay.
Okay.
Yeah. Then we are done with this so that you can do all the exercises at home. That's fine. Then
Okay.
we'll start the second unit from next day onwards, and also I have the past paper questions as well, or unit wise. So since we are done
Uh-huh.
P1 එකට තියෙන past papers questions and also S1, I will send those two as well. So leisurely, there's no any hurry. So
Yeah.
you can take your time and do those ones as well, Karan. So I'll send you the answers as well. I mean, I have the proper answer sheets as well for the entire working, so that you can, once we finished one unit, we can complete, since it's A levels, no. So for the local A levels also, we normally do like that. Once we completed a complete lesson, then we'll try out the past papers again, unit wise past papers. So I'll
Okay.
send those ones as well, so that you can work on those ones. Okay?
Okay.
Okay. I hope this is also fine for you. So yeah, that's it.
Yeah, so far it's fine.
Yeah, that's the case. So anyway, that's fine. So we'll start with the second unit from next week onwards.
Okay, teacher.
Thank you. See you on next week then. Bye.
Okay, see you, teacher. Bye. Have a nice day. Thank you.